Is the square root of 2 rational or irrational? The answer, perhaps surprisingly, is irrational. How can we be so sure? Let's delve into a proof by contradiction and see where it leads us. Imagine for a moment that the square root of 2 is rational. This implies it could be expressed as a fraction in its simplest form, with p and q being integers and q not equal to 0. So we could write the square root of 2 as p over q. Squaring both sides of this equation transforms it into 2 equals p squared over q squared. Multiplying both sides by q squared gives us 2 times q squared equals p squared. At this point, it becomes evident that p squared is an even number, as it equals 2 times a whole number. Consequently, p must be even. This allows us to express p as 2 times n, where n is another whole number. Substituting p with 2n in our equation translates it into 2 times q squared equals 4 times n squared, or more simply, q squared equals 2 times n squared. Similar to our prior deduction, q squared is also an even number, which implies q must be even. But wait, there's a hitch. We initially assumed that p over q was in its simplest form. However, if both p and q are even, we could divide them by 2, contradicting our initial assumption. So what does this mean? This contradiction tells us that our original assumption that the square root of 2 is rational must be incorrect. Therefore, the square root of 2 is indeed irrational. This proof, a classic example of proof by contradiction, underscores the power of contradiction in mathematics. It allows us to confidently assert the existence or non-existence of certain mathematical realities. In this case, it helps us understand the nature of irrational numbers like the square root of 2. A seemingly simple question opens the door to a profound understanding of the mathematical universe.